Fourth problem in the exercise 8.1. Prove that a line drawn through the midpoint of one side of triangle parallel to another side bisects the third side. To show this statement, we have to use basic proportionality theorem. Let us draw a diagram for the given data. This is a triangle ABC. In this triangle, a line drawn through the midpoint of one side of the triangle. Let us take the side AB. The midpoint of side AB is D. Through this point, we have to draw a parallel line to another side. This is a line parallel to another side BC. Now, this line divides the third side into two equal parts. That means this DE line bisects the third side AC. That we have to prove. See, dear students, what is given here? In this triangle ABC, D is the midpoint of AB. So, in triangle ABC, D is midpoint of AB. So obviously we can write AD is equal to DB. Am I right, students? Since D is the midpoint of AB, we can write AD is equal to DB. And also we can write AD by DB is equal to 1. Because AD and DB both are equal, if you divide both same quantities, you will get the answer 1. Now, in the triangle ABC, DE is parallel to BC. That is given, no? This is a line drawn parallel to one side of the triangle, that is BC. So DE is parallel to BC, so that we can apply basic proportionality theorem in the diagram. In triangle ABC, DE is parallel to BC. By basic proportionality theorem, we can write AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. Since AD by DB is equal to 1, we can substitute here 1 is equal to AE by EC. Then if you take this EC to the left hand side, it will multiply. So EC into 1 is equal to EC. EC is equal to AE. Now in the diagram, EC becomes is equal to AE. So we can conclude that since EC is equal to AE, that means E is the midpoint. E is midpoint. E is midpoint of AC. That means this DE line bisecting the third side AC. This is problem number 5 in the same exercise. It is a similar problem which we solved previously, but there is a slight difference. Prove that a line joining the midpoints of any two sides of the triangle is parallel to the third side. Did you remember, students? This is called midpoint theorem, which we learned in ninth class. That midpoint theorem we need to solve now by using converse of basic proportionality theorem. See the statement one more time. Prove that a line joining the midpoints of any two sides of a triangle is parallel to third side. Let us draw a diagram. This is a triangle. In this triangle we have to select any two sides. Let us take the sides AB and AC and select the midpoints. D and E are the midpoints of the sides AB and AC. Now if you join these two midpoints by a line segment, we have to show that this line is parallel to BC. For that, here I am taking, since D is the midpoint of AB, the lengths of AD and DB are equal. So we can write AD by DB. AD by DB is equal to 1. Since D is midpoint of AB, D is the midpoint of AB, AD by DB is equal to 1 because the length of AD and BD are equal. Similarly, since E is the midpoint of AC, here also we can write AE by EC is equal to 1 because the length of AE and EC are equal since E is the midpoint of AC. Now what happens here? AD by DB is equal to 1, AE by EC is equal to 1. So that we can conclude, therefore, AD by DB is equal to AE by EC. By the converse of basic proportionality theorem, by converse of BPT, since AD by DB is equal to AE by EC, we can conclude that DE is parallel to BC by converse of basic proportionality theorem. DE is parallel to BC.